All right, the keratins are made of keratins, and the keratin is a family of fibrous structural proteins. Those are the fibers. Anyway, keratin is the key structural material making up the outer layer of human skin. It isolates you. It's also the key structural component of hair and nails and so forth. Keratin monomers assemble into bundles to form intermediate filaments. And they're tough, and they form strong, unmineralized tissue found in reptiles, birds, and mammals. The only other biological matter known to approximate the toughness of keratin tissue is chitin. And chitin is a long-chain polymer, a derivative of glucose found in many places throughout the natural world. It's in cell walls and exoskeletons of arthropods and crustaceans. Anyway, that's what the keratins are all about. They are the things that protect us from dissolving when we get swimming in chlorine and everything else. They're virtually indestructible. And the same thing around wraps all your is in fascia. Keratins are heavy in the fascia that protects all of your organs and your muscles and separates them from the other ones. And they're wrapped in fabric bags as well. And I show that in the fascia facilitated fossilization, because the fascia is what protects all of this stuff from being dissolved when it's inside compacted mud. All right, I know you've probably heard me talk about sublimation before, vaporization, virtually the same thing. It's where elements heat and pressurize to a point where they vaporize and they gas off. Sometimes they melt first and then they gas off, and sometimes they go right from the solid state into the gaseous state. But that's sublimation. In other words, just take it this way: they gas off, they leave. Now, all of these here, 99% of the human body is made up of these different types of things, and all of these things have a very low sublimation point. So under the pressures of the deep earth, they gas off and they go away. And what you end up with is the carbon, which has an extremely, well, it's the top of any of them, of any chemical at all, any element at all, and then you end up with these down here, which are the metals, basically, and those don't vaporize off. So these end up creating the source crystallization to propagate crystals within these organic materials that are being transitioned into different chemicals. They're being gassed off, they're being turned into bitumens and gases and oils, and they're also being turned into crystals because the life process concentrates these things, irons and so forth, in different areas, and silicon, and it does it by the process of life needing these things to be accumulated in these particular areas to do tendon jobs and to do other organ jobs and things of that nature. To the keratins and so forth, and the carbon is created to form the bags that hold the cells, all the goo inside the cells. This is just the way it's built, and all of these things go away except the carbon. Now, sublimation in mud fossils creates copies of them, exactly like the petrified forest. Now, these were tree trunks, and obviously tree trunks don't deteriorate the same way as human flesh and animal tissues and so forth. But you can see that they have been encapsulated. Well, it says right here, petrified wood is not rare. It's found in volcanic deposits, sedimentary rocks at many locations worldwide, sometimes found where volcanic activity covered plant material with ash, mud flows, which is the stuff that we're working with here, and these are cold mud flows from a glacial drain. But these were mud flows, pyroclastic debris. It's found where wood in sedimentary deposits was replaced by minerals precipitated from groundwater, and that's identical to what I have here. It's identical, and they do the exact same thing. It's especially abundant around coal seams, although many of the wood specimens in these, da, 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 da. Anyway, the idea behind this is that these woods have coatings around them that protect them from the environments, just like our keratins protect us from the environment. When they got buried, they were protected from the mud on the outside. Now, rotting in oxygen and so forth, yes, it will destroy it. But deep buried in these muds and compacted under these conditions, anaerobic conditions, then nothing happens to them. So what happens is the percolated silicates and so forth that are coming down through the soils invade the plant tissue and eventually petrify it, mineralize it. And it's the exact same process that we have here, identical.